We continue reading through Electrical Safety Student Manual. Improper grounding hazards. When an electrical system is not grounded properly, a hazard exists. The most common OSHA electrical violation is improper grounding of equipment and circuitry. The metal parts of an electrical wiring system that we touch, such as switch plates, ceiling light fixtures, conduit, etc., should be grounded and at 0 volts. You also have the chassis of appliances such as electric stove, washing machines, and so on. If the system is not grounded properly, these parts may become energized. Metal parts of motors, appliances, or electronics that are plugged into improper grounding circuits may be energized. When a circuit is not grounded properly, a hazard exists because unwanted voltage cannot be safely eliminated. If there is no safe path to ground for fault currents, exposed metal parts in damaged appliances can become energized. Extension cords may not provide a continuous path to ground if there is a broken ground wire or plug. A fault current is any current that is not in its intended path. Ground potential, the voltage a grounded part should have 0 volts or negative, or 0 volts relative to ground. If you touch a defective line or live component that is not grounded, you will be shocked. The GFCI is a ground fault circuit interrupter. It is a device that detects current leakage from a circuit to ground and shuts the current off. If you contact a defective electrical device that is not grounded or grounded improperly, you will be shocked. You need to recognize that an improperly grounded electrical system is a hazard. Electrical systems are often grounded to metal water pipes that serve as a continuous path to ground. If plumbing is used as a path to ground for fault current, all pipes must be made of conductive material, a type of metal. Many electrocutions and fires occur because during renovation or repair, parts of metal plumbing are replaced with plastic pipe which does not conduct electricity. In these cases, the path to ground is interrupted by a non-conductive material. Well, of course, when those pipes that are used for grounding are replaced by plastic pipes, an electrician should be asked to install a ground rod to replace them. A ground fault circuit interrupter, or GFCI, is an inexpensive lifesaver. GFCIs detect any difference in current between the two circuits, the two circuit wires, the black, that is live, and the white wires, neutral in America, black and white here. In other countries, you may have red wire for the live and blue for the neutral. This difference in current could happen when electrical equipment is not working correctly, causing leakage current. If leakage current that is a ground fault, is detected in a GFCI protected circuit, the GFCI switches off the current in the circuit, protecting you from a dangerous shock. So what happened is that the current coming from the plug should be equal to the current going back to the plug. You may, however, have current coming from the plug to an electric drill through the hand of the person holding the drill and going to the ground, and only some of the current going back. The GFCI detects this, the GFCI plugs detects this and cuts the current off. GFCIs are set to about 5 milliampere and are designed to protect workers from electrocution. That means if you have 100 milliamperes coming out of the plug and 95 or less milliamperes coming back, then the GFCI will detect that difference. If 96 milliamperes are coming back, only 4 milliamperes are missing, so the GFCI would not detect that. However, the person probably would be able to let go of the drill. But if 95 milliamperes are going back, it means 5 milliamperes are leaking through the person's body and the GFCI trips. If less, for example, 94 milliamperes are going back to the plug, then 6 milliamperes are shocking someone going through their body to the ground. And the GFCI will detect that and trip. And they can trip within 1/40th of a second. Leakage current is a current that does not return through the intended path but instead leaks to ground. And it could be leaking from the person's hand through their body, down their feet and to the ground. Ground fault is a loss of current from a circuit to a ground connection. GFCIs are able to detect the loss of current resulting from leakage to a person who is beginning to be shocked. If this situation occurs, the GFCI switches off the current in the circuit. GFCIs are different from circuit breakers because they detect leakage current rather than overloads. Nowadays, you do have some circuit breakers that are GFCI circuit breakers, but they are also designed to trip and overload, so they have both features. If you have a GFCI plug, it should be accompanied by a GFCI circuit breaker. And by plug, I mean the receptacle, as in this case. This is a GFCI receptacle. Right? Circuits with missing, damaged, or improperly wired GFCIs may allow you to be shocked. You need to recognize that a circuit improperly protected by a GFCI is a hazard. Overload, too much current in a circuit. An overload can lead to a fire or electrical shock. Overload hazard. You can look at this circuit, you can see that it's likely well overloaded. If each of these plug is only controlling a cell phone charger, it may not be overloaded, right? You have 1, 2, 3, 4, 5, 6, 7 connected to this extension or this power strip. However, if you have one plug to an electric iron, another to a television, and another to a computer, you are likely to have an overloaded circuit. Overload hazard. Overloads in an electrical system are hazardous because they can produce heat or arcing. That's the arcing would be a spark, electric spark, and the wire would be hot enough to feel warm, and that should not happen. Wires and other components in an electrical system or circuit have a maximum amount of current they can carry safely. If too many devices are plugged into a circuit, the electrical current will heat the wires to a very high temperature. If any one tool uses too much current, the wires will heat up. The temperature of the wires can be high enough to cause a fire. If their insulation melts, arcing may occur. Arcing can cause a fire in the area where the overload exists, even inside a wall. In order to prevent too much current in a circuit breaker or fuse is placed in the circuit. If there is too much current in the circuit, the breaker trips and opens like a switch. If an overloaded circuit is equipped with a fuse, an internal part of the fuse melts, opening the circuit. Both breakers and fuses do the same thing. They open the circuit to shut off the electrical current. Well, there's a bit difference here now. With the fuse, you have to install a different fuse with the same specifications, of course. And with a circuit breaker, it will show that it has tripped. You correct the situation that caused it to trip, then you turn it off and then back on, so you don't have to buy a new circuit breaker. Circuit breaker is an oval current protection device that automatically shuts off the current in a circuit if an overload occurs. Trip, the automatic opening or turning off of a circuit by a GFCI or a circuit breaker. Fuse, an overcurrent protection device that has an internal part that melts and shuts off the current in a circuit if there is an overload. Circuit breakers and fuses that are too big for the circuit are dangerous. Example, using a 30 amp fuse in a 20 amp circuit. So in that case, the 30 amp would see 25 amps as just normal current, thinking that it's a big machine that's being operated. However, it's a fault current and it did not trip because the circuit breaker is too large. Circuits without circuit breakers or fuses are dangerous. Circuit breakers and fuses are really protection device, and you need the protection there. If these breakers or fuses are too big for the wires they are supposed to protect, an overload in the circuit will not be detected and the current will not be shut off. Overloading leads to overheating of circuit components, including wires, and may cause a fire. You need to recognize that a circuit with improper overcurrent protection devices or one with no overcurrent protection devices at all is a hazard. Overcurrent protection devices are built into the wiring of some electric motors, tools, and electronic devices. For example, if a tool draws too much current or if it overheats, the current will be shut off from within the device itself. Damaged tools can overheat and cause a fire. You need to recognize that a damaged tool is a hazard. Damaged power tools can cause overloads. Damaged equipment can overheat and cause a fire. Wet condition hazard. We will look at wet condition hazard in a different video.